Okay, 21st century students, now comes the time for the review for your Chapter 11 test. And there's also a practice test in your folder this week. So you should take the practice test. Remember, the key will be up on Schoology for you to check when you get done. And you do not have to turn in the practice test to me. That's just for your benefit. But if you have questions, remember I'm available during that help time 2 to 4 each school day. So this chapter began with some vocabulary. So that's how we're going to begin the review here. The first thing they ask us to do is to name a central angle. A central angle has to have its vertex at the center of the circle. So a central angle would be one such as BED. So there is a central angle. It has to be named with an angle symbol, and the vertex, the E, has to go in the middle, so BED. A radius. Now, a radius can be named in a couple different ways. A radius can be named as a segment, or it can be named as a distance. When we're asked to name it, it's often best to name it as a segment. So this would be an example of a radius right there. So I'm going to call that segment E to D, and I'll put the segment symbol on the top. An inscribed angle. An inscribed angle is sometimes called an on angle, and that's because the vertex is on the circle. So an inscribed angle could be D to A to C. That would be an example of an inscribed angle, and the A would have to go in the middle. So D to A to C. A chord. Now a chord must be a segment. So we have to use a segment symbol. And it has to have both of its endpoints on the circle. So A to C would be a chord. Segment AC. A diameter. A diameter is a segment or a distance. It has to go all the way across a circle through the center. So if we look up here, it would be A to D, and we'll name it as a segment, AD. A major arc. Now, major arc means it's more than 180 degrees. And we have to use 3 letters. So I believe that if I started at D and I went all the way around to B, so I'm going to name that DAB. And then I have to put an arc symbol on the top. A secant. A secant must be a line. So when I name it, I have to use a line symbol. But they don't have to put the line symbol in the diagram. So if I name the line AC, even though they don't draw it continuing out, that would be considered a secant. A minor arc. A minor arc must be less than 180. And we use 2 letters. So D to C with the arc symbol. A semicircle. Now a semicircle has to be exactly 180 degrees, and it uses 3 letters. So DCA with the arc symbol. And then a tangent. A tangent can be a line or a ray or a segment, but it can only touch the circle at one point. So I'm going to name it, let's see, H to B. And I'll name it as a segment. So that's the vocabulary. The rest of this is really going to be working out some problems, and we'll identify which type of angle we're working with first, and then we'll go ahead and solve it. So this was what we called an inside angle. And an inside angle was equal to half the sum of the arcs. So the x would be equal to half 56 plus 47. So the x would be equal to 51.5. The second one we see here, we called an outside angle. The outside angle is equal to half the difference of the arcs. But as often happens, we have to find a missing arc. So we're going to find this missing arc. We'll take a full circle. We'll subtract 63 minus 162 minus 59. We find out that that missing arc is 76 degrees. So now our angle x would be equal to 1/2 the larger intercepted arc, that's the 162, minus the smaller one, that was the missing one we just found. So the x comes out to be 43 degrees. The next one. Now, this is the one that we said could be thought of as an on angle. An on angle is an inscribed angle. It's just equal to half of the arc. So the x here will just be half of 168. So the x will be 84. Now here we have a situation where they gave us information about two different angles. The angle ABC. Now the arc that goes with angle ABC is this one. And then the other angle that they gave us was angle ADC. Both angles intercept the same arc. So the angles are equal or congruent. So we'll set those expressions equal to each other. 11x minus 4 equals 9x plus 2. To solve it, I'll subtract 9x. We'll add 4. Divide by 2. We get x equals 3. Now to find the measure of angle ABC, I have to plug that back in. 9 times 3 plus 2. The measure of angle ABC will be 29. Two inscribed angles or on angles with the same intercepted arc are equal to each other. They're congruent. This one. Now this one's asking us for an angle again, and the angle is an on angle, angle ABC. We can see it intercepts a semicircle. So I know this is going to be half of 180, so it's just 90. Really, we don't have to do any work on that because anytime you have an on or inscribed angle that intercepts a semicircle, it's going to be 90 degrees. We got that from taking half of 180. Now here we have two things working for us. We have an inscribed quadrilateral. And in an inscribed quadrilateral, the opposite angles are supplementary. In this particular one, we're going to find the y first. And that's because the y is an on angle. It will be equal to 1/2 of the arc. And if you think of the angle y is this one. And the arc that goes with it is this one. So that blue arc will equal 158 plus 54, so that will be 212. So that whole arc is 212. So that means our y would be equal to half of 212. So the y will be 106. And now we'll use that fact that the opposite angles are supplementary. So x plus 106 will equal 180. So x will be 74. And that's why we had to find the y first. Okay, now in this problem, they gave us the measure of the angle A to B to D. A to B to D is this one. That's a central angle. They ask us for the measure of the arc A to D. Well, a central angle is equal to its arc. So that means the measure of arc AD is going to be 35 degrees. Really no work to do. Now in this one, again, I think it's best to go ahead and fill in everything that we know. For instance, we have vertical angles. And they're congruent. So this one would be 52 degrees. That means this arc is 52. This arc is 29. I can take 180 minus 52 minus 29. 180 minus 52 minus 29. I come up with 99 for this one. This would be 99 as well. This would be 52 as well. And if I take 180 minus 52, I get 128. So this is 128. This is 128. Okay, let's go ahead and find out what we can. So we already found the measure of arc D to E, 52 degrees. Angle AOE, A to O to E, we already found that one, 128 degrees. Angle D to O to B. Now that one's going to be DOB is 29 plus 99. 29 plus 99, 128. So filling in all that information right from the start really saved us some time, I think, when we went to get our answers. Okay, on this one, they gave us the arc from C to D was 158. So that's really this arc from here over to here. That's 158. Well, oops, sorry about that. I think that we can find this one right here. We'll just take 180 minus 158, and we get 22. Okay. And then they told us the measure of angle ACD was 3x plus 2. ACD. So this angle right here is 3x plus 2. Now, that's an on angle. An on angle is equal to half of the arc. So that on angle, that 3x plus 2, will be equal to 1/2 of the 22. The 3x plus 2 then will be equal to 11. 3x will be equal to 9. X will be equal to 3. So once again, we filled in what we knew, then we figured out what kind of angle we had, then we filled in our information. Now, to do this one, I think we have to find the missing arc. So our first step is going to be finding the missing arc. Now, to find the missing arc, we once again have an on angle. The on angle will be equal to 1/2 of the arc. So the 36 degrees, because this is our missing arc right here, the 36 degrees will be equal to 1/2 of the arc. We know that when we have this situation, we multiply by 2. So 72 degrees will equal that missing arc. And now we're going to use the whole circle. A whole circle is 360 degrees. So 124 plus 72 plus 12x plus 8 is equal to 360. Combining like terms, we have 124 plus 72 plus 8, 204. We'll subtract 204 on both sides. We get 12x equals 156. Divided by 12, x equals 13. Okay, let's try another. This one's an outside angle. It's equal to 1/2 the difference of the arcs. First thing we have to do is find the missing arc. And again, the missing arc would be this one, right here. That missing arc is going to be 360 minus 92 minus 78. So that's 190. And now we'll fill into our formula. The outside angle was 6x plus 2. And that's equal to 1/2. And then the difference of the arcs would be 190 minus 78. 6x plus 2 would be equal to 56. Subtract 2, 6x would be equal to 54. Divide by 6, x would be equal to 9. Okay, inscribed quadrilateral. Opposite angles, supplementary. So that means the 12x plus 5 added to the 7x plus 4 will equal 180. Combining like terms, 19x plus 9 equals 180. Subtract 9, 19x equals 171. Divide by 19, x equals 9. Okay, number 25 is one of those problems where we have several questions that deal with the same diagram. So again, I think the most helpful thing is to go ahead and mark everything you know on the diagram to begin with. So they gave us the arc from A to D was 148. So this arc right here to here is 148. I believe that means we could get this part right here by taking 180 minus 148. So that comes out to be 32. They also told us that the angle ACB was 61. A to C to B. So this one is 61. Okay. Now, the 61 is an on angle. So that equals half the arc. So I think that means we can get this arc out here by taking 2 times 61. 2 times 61, 122. Okay? And then I think we can get this arc right here. We'll take 180 minus 122, and we get 58. Okay, so let's see what we can do. Angle 1. Angle 1. Angle 1 is an on angle. It equals half of the arc. So the measure of angle 1 will equal half 58. And half of 58, 29. Angle 2. Angle 2 is a central angle. It's equal to the arc. So angle 2, 122 degrees. Angle 3. Angle 3 is an on angle. It equals half of the arc. So the measure of angle 3 is half of a semicircle. So it's 90. Angle 4. For angle 4, we can use the sum of the angles in a triangle. So the measure of angle 4 plus 122 plus 29 equals 180. So I take 180 minus 29 minus 122. I get 29. Measure of angle 5. Angle 5, on angle, equals half of its arc. Measure of angle 5 would equal half of 148. So it's 74. And the measure of arc BC, well, the measure of arc BC we actually have written up there. That's 58. So by labeling everything we could in the beginning, I think it really shortened when it came time to fill in our answers. Last question on the review. The last question on the review here is an inside angle. And an inside angle is equal to half the sum of the arcs. So the 8x plus 5 will equal half 52 plus 182. So the 8x plus 5 will equal 117. Subtract 5, 8x equals 112. 112 divided by 8, 14. Don't forget to do the practice test.